Hey people. So today we're talking about solving by completing the square. So at the very top here it says completing the square is used when a is equal to 1 and the problem cannot be factored. So we would be in a situation like this, but instead of b and c you would have two numbers there. And those two numbers would not be able to be factored. So remember, factoring was when we used that giant X where we had a times c at the top, b at the bottom. We use this when that doesn't work, okay? So let's take a look at these. It says for number 1 that we have x squared plus 6x plus 4. Typically, these will have an equal 0 on it, but I forgot to write that in, so we're just going to ignore that for right now. But we can see that we have two steps here for each problem. We have a model and we have a solve side. So for the model, what I mean by that is we need to draw a picture. Now in class, we use these things called algebra tiles. And these algebra tiles had different shapes that represented different parts of our problems. So for this problem, we have an x squared. That's going to be a large box that looks like this. We have 6 x's. X's are little rectangles like so. And then we had 4 for our constant. And those just look like this, little squares. Okay? And they fit together in such a way that you can make it into a square. Like a literal square. Like that's why it's called completing the square, is because you're trying to make a square out of all of these pieces. To do that, basically you're just going to move them around. Oopsies. You're going to move them around. And you want to make sure you have enough for each part of your problem. So like we're starting out here with my x squared. I only have one of those, so that's why I only have one large box. For my x's, I'm going to use these rectangles. So I got 1, 2, 3. And then I'm going to put 3 more at the bottom here, because that's going to be the easiest way to create that square shape. I don't want it to be a rectangle. I want it to be a square. Okay, so I got 6 of them, and then I need 4 little squares. 1, 2, 3, 4 of them. Okay, so this is representing this problem. This is a physical, or rather visual picture of this problem. Okay, and what we're going to do is use this picture to write out a new problem over here. The way we do that is by creating a problem that's going to be in HK form, basically. Remember, HK had that set of parentheses that was squared on it. We're going to bring that back for a second here. It's been a while since we talked about HK. Almost all of our problems now have been in standard. So the way we do that, you are going to fill in some pieces here. All of these, the parentheses x plus parentheses squared, those are always going to be there. What you need to fill in are these pieces over here. To do that, I am going to look at how many x's I have on the side and at the bottom here. I have 3 of those. And basically what's going to happen every time, it's going to be half of whatever your b is. So I got 3 for those. So what I want to do is put in a 3 in my problem. And then I'm also going to look at how many pieces I am missing here. Because remember, your goal is to complete the square. So in this space down here, I want to count how many I should have in that space. So let's see, I got 1, 2, 3, 4. Looks like I can do 5, 6, 7, 8, 9 squares could fit in that space. So I'm missing 1, 2, 3, 4, 5 of these guys. 5 missing. So I'm going to put that missing amount on the side over here. Now I know I'm not going super in depth with this, and that's because you're going to do this again in Algebra 2 and like really dive into it. So we're going to do like the short version right now. But that's the first part of these problems, is creating the model. The second part of it is going to be solving. So what I want to do is just copy over this problem over here. So I had x plus 3 squared equals 5. Okay. That has been copied down. It's the same thing. None of those numbers changed. I'm just going to take that, put it over here. Our next step is going to be actually solving this, like getting that x by itself. So I'm going to draw my line, separate this into two sides. And I'm going to look at this. I'm seeing that I have this set of parentheses with the squared on the outside of everything. I need to get rid of that first. Remember when we were solving, the first thing we did was parentheses. So to get rid of this squared, what I'm going to do is square root both sides. Because I know that from last time, or from when we were solving by radical, this square root sign will get rid of all of those pieces. So when I do that, I'm just going to be left with x plus 3 on this side. And then I want to take the square root of 5. However, I know that 5 is a prime number, and when I try and go and factor it, the only two factors I have are 1 and the number itself, and we don't want that when we're factoring. So I can't really do anything to that 5. So what I'm going to do is put a plus or minus sign, because we always need that, and I'm actually just going to leave it inside the radical because I don't have any factors that will work for this. And then I'm going to continue to try and get this x by itself. So I have x plus 3. I want to get rid of that 3 next. So I'm going to subtract 3 from both sides. When I do that, these are going to cancel out. I'll be left with x equals, and then I'm just going to rewrite this because this square root of 5, I can't really do anything with that. I can't subtract from that number. I can't add anything to it. So I'm just going to leave it alone, and I'm just going to rewrite the problem since I can't really do anything else with this. And since I can't do anything else, this will actually just be my answer, is that x equals negative 3 plus or minus 5. So when it says answer, that's what I'm going to put. Negative 3 plus or minus the square root of 5. You could break this up into two pieces and say negative 3 plus the square root of 5 and negative 3 minus the square root of 5. But since we can't really solve that part, I'm really just going to leave it like this. But that is an option that you can do and it would still be correct. But that's what we have for completing the square. So let's do another one. Let's do the next one. We have x squared plus 4x plus 3. Okay, first part is making the model. Remember, when you're making the model, you want to try and think about those algebra tiles. You want to rewrite this problem, but with shapes. So I know that big square is going to represent my 1x squared. I need 4 x's. Remember, those x's were rectangles. I'm going to take half of them and write them on the side. I'm going to take half of them and write that at the bottom. Okay, then I need 3 for my constant, so those are going to be the little squares. 1, 2, 3. Cool. We're going to use this model to rewrite the problem over here, but in a slightly different way. When I rewrite this problem, I know I'm going to have parentheses x plus something equals something, okay? I'm going to get those pieces from my x's first. I'm going to count how many I have on the sides and at the bottom. That is 2 x's on each side. So I'm going to write a 2 here. Oh, I forgot my squared. And then for the other one, I need to count how many missing pieces I have. I see only 1 spot available here, so I'm going to say there's only 1 missing. And I'm going to write that 1 over here. And that is the first part of this problem done. You need to use your model to create a new problem. After that, we're going to solve. So I'm going to take that equation that I just created. That was parentheses x plus 2 squared equals 1. And I'm going to start solving it by getting that x by itself. I'm looking at this. I'm seeing these parentheses and the squared are in my way. So I am going to get rid of those by square rooting both sides. When I do that, I'm going to be left with x plus 2 on this side. And then I want to try and take the square root of 1. Remember, you want to find the factors. For this one, actually, we would get a perfect square because 1 times 1 will give you 1. This is the only time where you're allowed to use 1s for your factors. So for this one, since I have that match, I still want that plus or minus sign, like we said before. And then I'm just going to write a 1, since that's my pair and I don't have anything that's left over. Okay, cool. So next thing, I still want to get this x by itself. So this plus 2 is in my way. So I'm going to say minus 2 to both sides. When I do that, these will cancel out. So I am left with x equals -2 plus or minus 1. Now, here is the difference between the last problem and this one. I'm looking at what my answer was before and what my answer is right now. I see that this one has a radical sign in it and this one does not. So, since this was a radical, I was not able to add or subtract anything from it. But for this one, I am able to do that because I do not have a radical here. I just have the number 1. So, like I said before, you could split this up into 2 pieces. I'm going to do that. I got -2 plus 1. And then I got -2 minus 1. And I'm going to solve those 2 parts. So I got -2 plus 1. -2 plus 1 is going to be -1. Oops, -1. And then I'm going to solve this part. I got -2 minus 1. So that's going to be -3. And those will be my 2 answers there. Okay, so we did 2 slightly different ones. They started out the same. The models started out, you know, exactly the same. Our equations look similar, but then once we got to this part here, it switched up a little bit because of that radical sign. All right, let's try one more. I want to do number 4 because this one has a negative number for our constant in it. So let's start this out again. I need my model. So I'm going to draw a visual representation of what we have here. So I have 1x squared, got that. I need 2 x's. Remember, those are these rectangles. So I'm going to take half of them on one side, half of them at the bottom. Cool, looks good. And then I have -3. Now, taking a look at this, I see there's really only one spot for me to put a square. So there's not enough space for me to write in 3 of those. When we have negative numbers, think of that as more missing pieces. So I'm just going to write those out on the side over here. And what I'm going to do is count, What I'm going to do is count 1, 2, 3, 4 missing pieces here when I'm looking at this. So when I go to write my equation, where I had x and all that stuff, I'm going to count how many x's I have on the sides. I had 1, so I'm going to write 1. And then I had 1, 2, 3, 4 missing pieces. And now that only happens when you have a negative number to start with, okay? So it's a little bit different. But since I have 4 missing pieces, I'm going to write my 4 over here. And the rest of this is going to go exactly the same way as the others did. So I'm going to copy my problem. I had x plus 1 squared equals 4. I'm going to start solving this. So I want to get rid of these parentheses and my squared. I'm going to square root both sides. I'm going to be left with x plus 1 over here. And then I want to try and find the square root of 4. I know that 2 times 2 will multiply to give me 4. And I have a pair with nothing left over. So I'm going to rewrite this as plus or minus 2. I'm going to take a look. I have this plus 1 that is in my way because, again, my job is to get that x by itself. These will cancel. I'm going to be left with x equals -1 plus or minus 2. Oopsies. Plus or minus 2. And then I'm looking at this. I am seeing that there is no radical here. This is just a regular number. So I can finish this up. I'm going to say x equals -1 plus 2 and -1 minus 2. And then I'm going to solve those out. So I'm seeing -1 plus 2. That should be a +1. If you're not sure on that adding and subtracting part, use your calculator. And then I got -1 minus 2. That's going to be -3. And that's what we got for completing the square. Let me know if you have any questions. This one was a little bit different than all the rest that we have done so far. So please let me know if you have questions. I know this one might be a little bit confusing, but I hope you guys have a good day.